Tools for automating analysis pipelines. So this is going to be a very high-level view, basically an introduction to some of the concepts, some of the reasons why you might want to explore using one of these tools. I won't delve too deeply into any one per se, but again, just sort of a high-level overview to introduce some of the concepts and some of the reasons. So an outline. So very briefly, I'll just say what is an analysis pipeline in case somebody doesn't know. I'll talk a little bit about the difference between running these manually versus automating it and some of the advantages. I will discuss what I've broken down into maybe 3 different kinds of these tools. I will talk about each of those concepts and sort of briefly show how they work. And then to wrap it up, just talk about some of the things that you should consider when looking into these. All right, so with that, what is an analysis pipeline? Well, essentially, you've got some data. You need to perform some operations or tasks on that data in some specified order, at which point you have some sort of output coming out the other side. So, I mean, looking at this, it looks fairly simple. You might not see a need to automate something like that that has only 3 tasks or operations. However, here's a bioinformatics pipeline. And you can see this is a little bit more complex. So again, maybe you could manage this, running each of these tasks individually, one by one. But look at this. So this, I would not want to run this one manually. I mean, I probably don't even want to run this automated. But there's an idea of how these pipelines can grow and how large and complex they can be. And then adding to this as well, there are other factors. So for example, what if you need to run these jobs or some of these jobs on a compute cluster? What if you need to access a database at one or more points throughout this pipeline? And then finally, you can see at the end, you might need to transfer files to some other location, maybe a web server or something like that. All right. So what do we do in these situations? Okay, well, we'll talk about, okay, so I talked about a couple of the issues with running large, complex, but a little more detail on that. So efficiency. So especially with that last pipeline, this is potentially a lot of work. You could see when you have many, many tasks that need to be run, but also the case where maybe you have a large number of samples that you need to run. Another hit on efficiency is the time wasted in between tasks. So imagine that you're halfway through your pipeline, you launch one of the tasks at the end of the day, and then you go home. Now this task might finish in an hour or 2, but then your workflow is essentially stalled until you come back to work the next morning. So, you know, if you have something automating this while you're not sitting there at your computer, then you can take advantage of that extra computing time. So as I pointed out as well, so file management, task management can become very complicated, especially when you have errors with your pipelines that occur along the way. When you're running many, many tasks and many, many samples, it can get very difficult to manage. So running stuff in this way also will require proficiency in Unix, 1 or more programming languages, and also some knowledge of distributed computing, if that's something that you need to take advantage of. Now, one of the things is that a lot of these tools, or some of them anyway, don't actually fix this problem. To use some of these tools that I'm going to talk about, you're still going to need to know some coding, some command line, but for some of them you don't. So, and I'll talk about those as well. But another important aspect is reproducibility. So if you're running these manually and just sort of doing it in an ad hoc manner, and now you or someone else is sitting and looking at this data and wants to know, how was this generated? It can be difficult to gather all of that information. And in fact, that information might not even be available. Who ran it, what software versions, what parameters were used. Okay? So these are some of the issues with running pipelines or workflows manually. So conversely, some of the advantages of automated pipelines. So as you can see there, it says it varies from tool to tool, and it varies quite greatly. However, some of the kind of universal advantages are reproducibility. So as I mentioned, a lot of these tools will produce sort of global log files that you can, so at the end of every run, it will document every software or script that was run, what versions, et cetera, et cetera. They can also be portable, so many of them are cross-platform enabled. You can share your pipelines more easily, so if you if you have collaborators, for example, that need to run the same pipeline that you were running on their own data set, a lot of these tools will allow you to save, encapsulate a pipeline and save it and simply send it off. So another is visualization. So some, again, they will produce a DAG or a directed acyclical graph, which is essentially just a visualization of what happened or what is going to happen. And this is nice too. Some of them will actually, at the end of a run, will produce this visualization and actually color code the tasks according to whether there was it was successful, there was a warning, there was an error. So especially for large pipelines, it can provide an easy way for you to see very quickly how that pipeline, how it finished. So user friendliness is a big one. So some of these tools provide a GUI for building your pipeline. Others don't, but they do have other forms of code abstraction so that you don't necessarily have to write this code yourself. And finally, another advantage would be community. So some of the more well-known, more broadly used pipelining tools actually have communities where people will not only create pipelines, but they will make them available. So you can go to some of these community hubs, you can download somebody else's pipeline, and you can use it as is, or you can modify it. So that can actually save you some time if you're using a somewhat standard pipeline for, say, I don't know, RNA-seq or something like that. You can find somebody else's pipeline and then just tailor it to your needs. All right, so yeah, sometimes called workflow manager. So some people like to say pipeline has a different meaning than workflow. Other people use it interchangeably. I tend just to use them interchangeably as well. But there are very many of these. So I've listed a few here, but I think I scraped this off of a list that I found. Somebody had made an exhaustive list of something like 200 different pipeline tools. So which one do you use? Well, in order to answer that, really it's dependent on the user and the level of skill that they have, and also the amount of flexibility that they require. And so that will somewhat guide which tool you use. Also, what's available. Perhaps the system you're working on already has access to one or more of these. Maybe you're interested in one of these, and you go to your system administrator and say, yes, I'd like you to install this, and they'll say, no way. Because of various issues, some of them have security holes in them, et cetera, et cetera. So that's another factor to consider. Okay, so as I mentioned, 3 different kinds, at least that I could figure. And in order from low level to high level, so from the least abstracted to the most abstracted, our number 1 is a code-based tool. So essentially this is, there are packages in Python, for example. You can simply import the package and it gives you functionality to build your own pipeline, right, within your code. The second is configuration file based. So this is essentially, in building your pipeline, you don't necessarily need to write code, or you need to write maybe a little bit of code as a wrapper. But essentially, when you're building your pipeline, the way you do this is by creating a configuration file that specifies how this pipeline is run, and then you pass it to an engine that runs, that constructs this pipeline and runs everything on the back end. And then the third is a GUI-based. So this is the easiest to use, typically, where you're able just to sort of drag and drop the tasks in and connect them however you like. Now, there is a bit of a blurred line between number 2 and number 3, because a lot of these GUI-based solutions are also configuration file-based. So sometimes you will explicitly build this configuration file and pass it to a GUI-based tool. Other times, this is all done in the back end. So one way or another, it's going to use a configuration file. Just you may or may not actually see it. Okay, so first is the code-based solution. So again, this is just an example. There are many, many, and in fact, so within Python, I'm actually aware of 3 different packages that was on that list before. So the one I'm going to talk about is called Rufus. So this is a very simple example. You can see that the first line, you're simply importing the package. And then there are 2 functions defined, first task and second task, that simply just print out a string. But you'll see that the second task is what it has in Python is called a decorator. And so this is actually a part of the Rufus library. And you're basically instructing the second task to run after the first task. Okay, so now this looks really easy, and it is pretty easy. However, this is for just a very, very basic case. When you start having to specify things like inputs and outputs, if you need to launch on a cluster, you'll need to use some of these decorators to split your files or to aggregate them again. So again, it's more complicated than this, but this sort of gives you the gist of how it works. Okay? So now that you've created this little script, the execution, so I think that would just be within your Python interpreter. You do pipeline run, and notice you pass it the second task. So that's kind of an interesting thing that, well, maybe I'll just talk about it now. So, okay, well, we'll look at the output here. So even though we've passed in the second task, you can see that the output, the first task was completed first, and then the second task. And so the reason for this is that this actually will create a graph, an acyclic graph, but it works backwards. And the reason for this is that it's able to pick up where it's left off. So say there's an error in the middle of your pipeline and it crashes. You don't need to go and figure out how to relaunch your pipeline from somewhere in the middle. You still need to rectify the problem. But what this will do is it will start at the end of your pipeline once you relaunch. So you will launch it the same way that you did the first time. And it works its way from the end. So it'll start at the second task and say, do I have everything I need to run? Am I ready to go? And so whether that's done through the presence of input files or sometimes it'll create a token file. So regardless of that, if those inputs are not ready to go, it'll say, no, I'm not ready, go back to the next task. And so in a larger pipeline, it'll continue working its way backwards until it's found the point where it left off, and then it'll pick up and run from there again. So I pasted a link here to they call it a 5-minute tutorial on using Rufus, and then at the bottom of this, there's a link to the full tutorial. But I think the simple tutorial is a good way just to get a little broader idea of how this works and what's involved. Okay, so configuration-based. So the thing about configuration file-based tools is that in the past, and still to somewhat of a degree, each of these tools that came out had their own configuration file. So maybe it was a YAML file or a Perl config file. But more importantly, the syntax of how you're setting up this configuration file was different. So what happened recently is that they've come out with this Common Workflow Language, or CWL. So essentially, this is a way, a standardized way to describe your pipeline and to specify it. Okay, so what's nice about this is that more and more of these automation tools have started supporting CWL, which means if I'm using tool A and I've generated my Common Workflow Language file, I can now I decide I want to use a different tool. I can simply port over my CWL file and run the same pipeline on a different platform. The other thing that's nice is you only have to learn how to do this one time. You don't have to, if you want to switch tools, you don't have to relearn the ins and outs of the configuration files. So, if you're interested in learning more about this, there's a commonwl.org is the link to go check out. So let's have a quick look at this configuration file just to get an idea of how it works and how you would set this up. So you can see on the left there, after some basic declarations, you've got inputs. So you're specifying, you've got a genome, which is a string, you've got an in file, which is a file, you've got a little space to document, and then you do the same thing for all of your outputs. Then in the right-hand pane, you'll see that you document the steps. So this pipeline has 2 steps. It's gunzip and then running snipf. So you can actually see that in the run section of these tasks, there is a reference to another CWL file. So this CWL file specifies the pipeline itself and how it's constructed. These other CWL files for the individual tasks will specify how that program is run. So perhaps the location of those inputs and the parameters that you want to use. Okay, and then just at the end, there's a space for documentation as well. Okay, and so if you're using a tool that doesn't support CWL, that has a configuration file, it will be a little bit different than this, but conceptually it'll be somewhat the same. Okay. Okay, so some people just want a GUI. Now this is the best solution for those of you that might not have command line experience, might not have experience using coding languages. Okay, so this one here, this one is specific to bioinformatics and life sciences analysis. There's another one called Taverna, which I believe is more general. It's another open source. I believe it's Apache. But this one here is specifically for bioinformatics. But anyway, the concepts should be more or less the same. So here you can see that there is a workspace. It doesn't show. There will be a pane on the left-hand side that lists all of the tools in their tool shed. And you simply drag and drop the tools that you want to run into the workspace. Now you can see within each of these boxes there's some information. So when you click on one of these boxes, it'll bring up a screen that will ask you what are the inputs, what are the outputs. You can set parameters, etc. And so now that you have the parameters set up, you have the tools, you simply connect them together in the order that you want them to run. So in this case, it goes sort of from left to right. You can see that the input data set is split to run 3 concurrent tasks. Then each of those tasks is filtered and then aggregated again at the end. So this is quite nice. You can see you don't really need to code. You just need to know where your files are and what the parameters are that you need to set. Now Galaxy, they had their own system for configuration files that was hidden on the back end. But last I heard, I'm not sure if they've done it yet, but last I heard was that they were working towards supporting CWL. Anyway, I also found this link at the bottom is a nice, it's a blog that somebody wrote, but essentially it gives sort of a nice brief outline of the steps that you would need to go through in order to create a pipeline using the Galaxy Workflow Manager. So that is what a GUI looks like. Now, oops. Okay, I forgot to move that. Sorry, that's a little garbled. So I mentioned community. So Galaxy is very widely used. This is just an example of an RNA-seq pipeline that somebody's built, and they've also shared it. So they have, there's a link to their GitHub repository. You can download this and save it. You can then put it into Galaxy and open it in the Workflow Manager and then change, add or remove tasks. You can change the parameters. So this is a nice sort of community aspect to this as well. So yeah, and so actually Galaxy, in addition to just having people have their individual repositories and sharing them individually, they've built this community hub. So you can see, and that's galaxyproject.org. So you can see there's a little search box on the right-hand side. So if you punched in, maybe you want whole genome analysis or something like that, you can search Galaxy. It will pull up not just other people's pipelines, but also tutorials and other information related to your search. So again, this is really a great resource for people without coding skills. So for those of you that want to use Galaxy on Compute Canada, you are in luck because there is a project called Jenout, which is essentially it's kind of a meta platform, I guess you might say. It is a platform that hosts some other platforms and is able to utilize the Compute Canada HPC resources in order to run them. So what Jenout is, it's got Galaxy embedded within it. And the nice thing about this as well is that so one of the issues with Galaxy is that it's kind of, especially if you're using the online version, is it's not a private instance. So in this case, when you create a project in Galaxy, it spins up your own private Galaxy instance, which is great. So they have some solutions for sharing and publishing your data. They also have already a collection of pipelines available, and then they also have public data sets available, and they also have embedded the UCSC genome browser. So if you're interested in using Galaxy on Compute Canada, I would recommend using this platform. So you just, it's available to anybody with a Compute Canada account. So you can just go to the link up there at the top, jenout.ca. And so yes, this is just a view of a screenshot of the interface for Jenout. So you can see it sort of provides this nice platform, really, where you can manage your projects and the people that have access to it as well. Okay, so then sort of to wrap this up, again, really which one of these you want to use depends on your needs, depends on your skill level. So using something like Galaxy or Jenout, or as I mentioned, Taverna as well, that provide the GUIs, if you're not very experienced on command line, then this is a great option for you, and I would encourage you to explore one or more of those. If you are adept at programming, you might want to take a stab at one of these Python packages. So I'm familiar with Rufus, but I think newer ones are actually SnakeMake and PyDoit. I don't know much about those, aside from the fact that they exist. So if you're interested in doing something like that, I would have a look at all three of them and see which one suits your needs. Now, I think one of the issues with doing this on your own is that you don't really want to be duplicating a lot of work that's been done. Like I said, there are all of these tools. So sometimes it might just make more sense to use something that's already done. However, if you have a small, simple pipeline, maybe you just have 2 or 3 tasks and you want to automate them, then this can be a nice solution because it wouldn't be very difficult to do. Okay? So other things to consider, when you're looking for a solution, you should check if it is compatible or if it supports the common workflow language. So as I said, there are some, and I think they list those on that commonwl.org website. But it's still it's only been around for a couple of years, so there's still more to come. But you know, this is something that you might want to consider, as it might save you some headaches in the future. The other thing to consider, if you're working on a distributed system, does that platform or the tool that you're working with, does it support that? Not only does it support it, but how well does it support it? I know with Rufus, I did some work with that. It does support distributed computing, not super great though, in my opinion. It did get a little confusing to do. Of course, is it available on my system? So if you're working on Compute Canada, you might want to see what's already available, like I mentioned, Jenout, for example. And then the other thing is you might want to use a tool that is fairly well known and something that's portable. So often you're working with collaborators, or if you are publishing based on the data that you are generating, you might want to post this pipeline solution as well, so that anybody who wants to reproduce your results can do it in an easy way. But like I said again, research these because there are so many. But hopefully this gives you kind of an idea of what's out there, the different kinds of analysis tools that are out there, and will set you on your way. So that's it.